All right, welcome back to microeconomics. So this week we will go into the second main topic of our course, which is production and supply. So we have finished with the demand side. Now we move to the supply side. And for this week, we will go through the concept of production function, productivity, isocons, marginal rate of technical substitution, and the final thing is returns to scale. As I mentioned with you a couple of times already, even though now it's a different context and also different perspective, however, most of these concepts we have made in the demand and choice part. It's just a different interpretation and you will grasp it very quickly. Let's go. Let's first start with the definition of the production function. So a firm's production function for a particular good shows the maximum amount of the good that can be produced using alternative combinations of capital K and labor. Note, however, that here capital and labor just convenient examples of the input. In reality, it could be any input depending on the context, right? For example, seed and fertilizers, two different input for producing agricultural products such as maize or wheat, right? Another thing is the production function is actually a summary of how you convert input into output. Why the maximum amount? Because that is set in ideal condition, right? In reality, there may be a loss of efficiency somewhere that is hard to manage or to predict. And in that case, maybe the output will be lower than expected. So the production function just shows the maximum amount. So you could think about it as the utility of the firm or the happiness of the firm. So we have the concept of utility, right? So that is the happiness of the consumer from consumption of goods. And on the supply side, production output is the happiness of the firm. So from now on, during this week in particular, I will try to relate the new concept we learn here with the demand part. Not to make you feel bad about not remembering it, nah? But in general, that would help you to link the thing that you learn. And I think it's quite helpful. Here is an example of a production function plotted in 3D graph of a Cobb-Douglas production function. So for example, here we have a production function Q output equals A technology times L labor to the power of alpha times K capital to the power of gamma. Now, and we plug some numbers here. So one thing to note here already is for the case of production functions, unlike the utility function before, remember I always said exponent summed up to 1. Here is not necessarily the case. So it can be equal 1 or larger than 1 or smaller than 1. Depends. We will see it more in the upcoming discussions, also in your assignments. What is implication when these exponents sum up to different value compared to 1? Now, so anyhow, it looks like a cake, right? A piece of cake. And one different thing from the production function to the utility function before. So now if you remember, I always said utility is a subjective concept. The first thing. The second thing is hard to measure. And it has that ordinality property, right? That means the preference matter, not the absolute value of the utility. So that was what we learned. However, for production function, it's much less abstract than that. So production is something you can measure. It's more or less more objective, not so subjective, right? You can measure it by particular level of output. And also, it is not always the case that more production always better, more inputs always better than less, like we said. So we see that more in the next section. So now go back to this piece of cake. So the height of this graph here, this dimension measure the level of output Q. So here we could write that like this because it's less abstract. And then the other two dimension again show how labor and capital changes. So here's output, right? So imagine if you slide this cake at a certain height. So every point on this surface, when you slide it, represent the same level of output. However, can be produced with many different combination of input. Let's take a look. For example, here, okay, now I choose this level of input. And that's required this much amount of labor, around 8 units, and that much capital, a little bit less than 3. However, we could also decrease the labor input somewhere to 7, around here, and we use more capital, around 5. We also will reach the same level of output. So that's to say that the production function has its flexibility, just like you have many combination of goods that bring you the same level of utility. You could also have many alternative combination of input to bring you the same level of production output. Okay, so here are some other production functions that you will often see in microeconomics, production economics, and we will go through some examples. So this is the Kaplan-Meier production function that we have seen on the slide. A general assumption about the parameter is alpha, beta, and A must be larger than 0. And that's the only thing. We don't have the constraint about A plus B equal 1 like before. I said that, right? And the second case is the qubit function, which has the form Q equal to alpha times K square L square minus beta times K to the power 3 times to the power 3. So one way to think about this production function that has like kind of this form. Now, for example, so it would be like this. let's talk about, for example, fertilizer and production of any kind of agricultural products. So as long as the fertilizer input is positive, of course you don't put negative input in your production, right? So as positive and increasing, the production will increase to some point, but at one point, if you put too much fertilizer in the soil, probably your production will decrease. So that's one example. The third one is the simple linear production function, which has the form alpha k plus beta L equals not equals over here, with alpha and beta positive. So for example, two K plus 4L equal Q equals F K L. How would it look like? Now imagine we fix K equal 2. So that will be Q equals 2 plus, sorry, not 2 but 4. 4 plus 4L, right? I have to practice writing the L will be a little bit different, not to confuse it with something else. How would it look like? If you graph the production on one, the vertical axis, and L on the other axis. So start over here, right? Because the intercept is 4. And we will increase linearly with L, right? So that's the linear production function. The next case is the Leontief, which has the form Q equals mean of alpha K and beta L, with alpha and beta larger than 0. So how to think about this Leontief production function? Imagine you have come back to the early 19th century with gold mining. So back to that time, the worker now had to use the spade to dig a pit, like a pit, and there's inside the pit you may find gold. Okay, so the production quantity is the number of pits. You have workers. Imagine now you have 5 spades. 1, 2, 3, 4, 5. Okay? It will look like this. Q again, and here is labor. You have 5 spades, so it's fifth, spades fifth. What if you don't have any workers? You don't produce any pits, right? So it's here. If you have one worker only can use 1 spade. So one person cannot use 2 spades at the same time and dig 2 pits, right? So it's like 1. If you have 1 labor. If you have 2 labor, it's like that. Increasing. Up to the point whereas, let's say here is 5. If you have 5 person, 5 spades, you have 5 pits, right? But then if you increase another workers, like you have the 6 workers, he has nothing to do, right? Because there's no spade. So workers and spade can't be substituted for each other. So it's fixed. And then the same thing, if you keep increasing the number of workers, nothing changes. You get no more pits, right? So this is how the production of the form relative look like. And because of this, it's called the linear limitational production function. Linear because it's like a production increase linearly, but only up to a certain level. If the other input doesn't increase, only up to a limit. So the linear limitational, that's the relative. The last case of production function we often see is the constant elasticity of substitution of the CS. You've seen that once in the utility function, I think. So in the production context, it will have the form Q equal K to the power of rho plus L to the power of rho. You know the Greek letters, right? That's right. It's rho. Okay. Everything to the power of gamma over rho with rho not larger than 1. This also should not be 0. I mean, there's a generalized case where it's 0, but then it's down to some other production function. You might see it in the textbook. And gamma larger than 0. So now this gamma especially will tell you about return to scale of the production function. So what return to scale is, and you have to follow to the end of this lecture.